Hi everyone, we are back and we're going to do our problem set 7 solution video. So we need expected values, totals of the table, total degrees of freedom, etc., etc. So let's go ahead and let's get started. So I'm going to open up. You should have an exam 2 prep notebook. But will this be for materials? Yes, it is for materials. Maybe this one. Maybe exam 2 prep. Here we go. So let's get our expected table. And then let's go down here. So I'm going to go ahead. I'm going to close this. I'm also going to close this. Don't save. So here. So we need 18, 19, 28, 1. And we're going to do 22, 17, 26, 10, 0. And then we're going to do 26, 15, 23, 13, 1. And then finally, we're going to do 21, 14, 17, 5, 3. We'll delete the rest of these. Good. We'll flatten this. We'll look at. Looks to be pretty correct to me. So that is our observed values. Our expected table is going to look as follows, like we see here. We can look at those expected values right here. And chi-squared experimental is 9.55. Degrees of freedom is rows minus 1 times columns minus 1. So number of rows, 1, 2, 3, 4. Columns, 1, 2, 3, 4, 5. So 3 times 4 should be 12. So if we look at our 10% significance, our chi-squared of 0.1, our nu is going to be equal to 12. We can pull up, hopefully it's here somewhere, one of our previous ones. Yep. So if we look at our chi-squared value of 0.1 and 12, that's going to give us a value of about 18.54. Let me just, 18.54. Our experimental falls in the do not reject regime, so that is going to be P is greater than alpha, because our value is 9.55. Now we could double check that in R by doing the following. So we can grab this. Let's go into R. We can forget about change these. Number of columns, I believe, is 5. So we have column 1, column 2, column 3, column 4. Then I'll do column 5. So, boom, 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 boom. Look at the data. Looks pretty similar. Chi-squared 9.5, degrees of freedom here. Everything matches. Fantastic. So, let's go ahead. Let's go back to the problem set. That's our first problem. Our second problem, we have another chi-squared. We have another contingency table problem. Let's go ahead. Let's change some of those values. 22, 2, 4, 2. We're going to go 8, 4, 4, 9. So we are do not reject, so basically we're saying the variables are independent. 3, 10, 10, 2. And the same thing here. 3, 10, 10, 2. Shift enter, shift enter. We can look and double check. Looks pretty good. Our expected table is here. And we can look at those expected values. And then finally, we can do chi-squared pretty high. So how many rows? 1, 2, 3, 4. 1, 2, 3, 4. So we're doing 3 times 3. So that's going to be a chi-squared of 0.19. That looks to be chi-squared of 0.19, 14.68. So that's going to be a reject. P is less than alpha. So they are indeed dependent. Fantastic. Okay. Finally, does A come from a population with a variance of this at a 5% significance? So let's go ahead. We'll pull up our R code. So we are going to use our chi-squared function here. So our number of samples for A was what? A was measured 12 times, so that's our number of samples. Does it come from a population with an S? S is my standard deviation, the experimental one, and that's standard deviation of 3. And then it's asking us, does the population, so that would be the square root because we're looking at variance. So I need to plug in 9.8. So my chi-squared experimental would be 10. So here, chi-squared experimental equals 10 something. And then we're looking at a chi-squared of 0.05. What are our degrees of freedom? In this problem, it's going to be n minus 1, which is 11. That is going to be equal to, let's go over here, 0.05, 11, 19.6. So that's a do not reject. Good. Does C come from population standard deviation greater than 0.4 meters or millimeters? You should see the typo there too, actually. You can get me on that one. System C, 22 times. It has a mean of this standard deviation of 8. And does it come from 8 and system C, 8 millimeters and 0.4? That's going to be a big difference. Oops, let me close that up. Oof, I don't even need to look up the value. That is definitely a reject as well. And that's it. So, we'll see you next time in the next problem set. The last one.